Hey, hello there and welcome back to another video. So today we are continuing with Advent of Code, as we do. So let's jump back to it. So yesterday we did, I want to remember where we were. Okay, growth positioning system. I think I missed yesterday that this is a play on GPS, the global positioning system. So yeah, we were decoding some numbers that we had to mix around. So now day 21, monkey math. The monkeys are back. These were the monkeys for the monkey business day, I think. Was monkey business? Yes, it was. I don't remember what that was about, but the monkeys are back. You're worried they are going to try to steal your stuff again, but it seems like they are just holding their ground and making various monkey noises at you. Eventually, one of the elephants realizes you don't speak monkey and comes over to interpret. I sort of had forgotten that the elephants were so intelligent, and it seems like I can communicate with them. As it turns out, they overheard you talking about trying to find the grove. They can show you a shortcut if you answer the riddle. Okay, each monkey is given a job, either to yell at a specific number or to yell the result of a math operation. Yell the result of a math operation. Okay. All of the number yelling monkeys know their number from the start. However, the math operation monkeys need to wait for two other monkeys to yell a number. And those two other monkeys might also be waiting on other monkeys. Okay. Your job is to work out the number the monkey named Root, that's a good name for a monkey, will yell before the monkeys figure it out themselves. Okay. For example, I guess this is a sample input. Root says PPPW plus SJMN. I guess these are monkey names. Okay. Each line contains the name of a monkey, yes, a colon, and the job of that monkey. A long number means the monkey's job is simply to yell that number. A job like AAA plus BBB means the monkey waits for monkeys AAA and BBB to yell each of their numbers. The monkey then yells the sum of those two numbers. Yes, and I guess this is the same, but AAA minus B, multiplication and division. I guess this will be integer division. I don't see any number with commas or decimal number or negative numbers either, so that's nice. So in the above example, monkey Dursum, let's search for Dursum. Okay, Dursum is doing this, has to wait for the monkeys to yell their numbers. Fortunately, both and have jobs that involve simply yelling a single number, so they do this immediately. 32 and 2. Monkey DRSM can then yield its number by finding 32 minus 1, 30. Why does it say finding? I guess calculating. Then monkey SJMN has one of its numbers 30. What do you mean by has that? Okay, so it's the result of this. Okay. And already has its other number 5 dB. Okay, I guess this is something that has already been calculated. Where is this thing? I guess this also means that this is the order of things, the order of monkeys shouting things. I'm not sure if how's the ordering affecting things there. This allows it to yell its own number by finding 30 multiplied by 5, 150. This process continues until root yells a number, 152. However, your actual situation involves considerably more monkeys. What number will the monkey named root yell? Okay, and we have the input. So I guess the input is just a bunch of these. All right. Okay, so I didn't really get if the order of the monkeys here makes a difference or not. I think it doesn't. It's just you have to like calculate or evaluate this operation for root and then sort of like recursively evaluate each of these until you end up in a monkey that just yields a plain number. Okay, so let's jump into this. Let's jump into Advent of Code and fire the editor. This doesn't seem too complicated for part 1 at least. So let's go to main. Let's add day 21. And how was this called? Monkey something? Monkey math? Monkey math. Wait, how was the other thing called? 11. Was it that monkey business? No, monkey in the middle, because apparently alliterations are all the rage in Advent of Code. It's either like an alliteration or a pun. The title is it's always one of those two. So this is monkey math. And we're gonna add this module run here and create a new file. Monkey math res public function run takes an input of string slice as usual and returns a string, and let's just return this. Sometimes I do to I sometimes just do empty string. And let's have an input file. Day 21 txt. You know what? At some point I started thinking that in these implementations I should have like a test for the sample case that they give in the description. So instead of like shuffling around the input file and changing from sample to actual input, I would just leave the actual input here and have like an inline test or a test for this module, or however it's called in Rust terminology, to just test the sample file, so I didn't have to shuffle things around so much. But I will leave that for maybe a general refactor later or next Advent of Code. Anyway, so we have these things. I guess the first thing to do will be to parse this into something. Or maybe let's think a little bit about how are we going to model this. I think a pretty straightforward model with enums pointing by ID to the different monkeys will be fine. And then we can have like a hash map from monkey ID to whatever this is called. Is this a monkey job, I guess? Yeah, it has a given job. Yes, so we can yell a number or an operation. That's nice. So yeah, let's say that we'll have something like let's monkeys be parse monkeys. Or you know what? Maybe Maybe we can do what we have been doing lately, which is just to say input lines and parse line or parse monkey, let's say, and collect. So we do a little bit of work here by separating into lines and collecting, and then we have a more specific function for parsing each individual monkey, and we are going to collect into a hash map of some things, and those some things will be like a monkey ID and the what and the monkey job. So let's sketch that out. Let's say that enum monkey job is going to be either a plain number. How does this call that thing? Well, yields a specific number, or they yield the result of a math operation. So I guess we can just say num is one case. And does it make sense to use? Well, I don't know if the numbers are going to be big or not, so let's start safe and just use 64-bit numbers. So it's either going to be num or one of the math operations, which I guess I can just enumerate here and set at, oh, but an addition is not between two numbers, it's going to be between a monkey ID and another monkey ID. So I think I want to do something like struct, oh no, not the struct, but a type alias, monkey ID, and have it be something simple like, because we could make the IDs just be a string slice of these, like a string, you know, of these names. But if we do that, we're gonna have to deal with, like, if we make this thing be a string slice, then we're gonna need to deal with lifetime annotation for like the lifetime of this slice. And if we make it be a string, then we'll be having like unnecessary allocation. So I think I'm just going to leave this as a plain array of 4 bytes, because it seems like all the names are 4 characters. So it's just going to be the ASCII code of those 4 characters, I think. So we're going to have add of monkey ID plus monkey ID, and then sub. And I'm thinking of, does it make sense to do this and repeat that all of these operations take 2 monkey IDs? Maybe it makes more sense to say, okay, it's either going to be a num or an operation, and have another enum for operations, and not repeat myself like this. I think we can probably get away with using this. Although, no, this will probably mean that when we are evaluating this, we are gonna have to evaluate both the left-hand side and the right-hand side for, like, there's gonna be more repetition about evaluating these two, whereas if I put an operation like this, we will be able to evaluate the left-hand side and the right-hand side once, and then call the operation, like the correct operation. I think I'm just speaking in the air, but let's say, like, I'm thinking too much ahead, I think. Let's do enum operation, and this is just going to be add sub oh, and div. Okay, great. Don't need a column there. And yeah, we need parse monkey function now. Let's see, this thing is going to take a line, which is going to be a string slice, and it will return a tuple of monkey ID and monkey job. Okay, and how are we going to do this? Well, the ID and job part are separated by this column, so let's say let's ID and job be line split once. We're gonna split by a string delimiter like this. Okay, and I think this split once surely returns an option. Yes, so we're gonna unwrap this and say that line should have a column. Okay, and then we're gonna parse the ID, parse the job, and call it a day, I think. So let's just say parse ID of this ID and parse job of this job. Look at that modularization. This should return a monkey ID. How do we do this? Well, I guess we can just say bytes return, I think, an iterator, but as bytes returns a slice, yeah, of U8. And can I make try into for this and unwrap? Does this work? Yes. Okay, but instead of unwrap, let's expect this thing. Yeah. Does this make sense? I think it does. Monkey ID should be 4 letters. Yeah. And now let's parse. No, let's generate this function. We're gonna parse a job. How are we going to do that? Well, I guess we can try to parse it as a number, and if that fails, we are going to assume an operation. So let's say let's num be as parse how do we want to do this? I guess we want to early return if it is a number. So we could say something like if parsing this as a number is something, then return monkey job number of this number. Okay. Else we are going to just leave this to do for now. It probably requires some type annotation, I guess. No, it's parses a result, not an option, but okay. Let's say if it's okay, yeah, it seems like it can know what is trying to parse. That's great. I don't have to use turbofish here. Otherwise, it's going to be an operation. So what do we have? We can just split 3 times, I guess, and have 2 IDs and an operation. So let's do, is there a split n? I don't think there is. Okay, now, so we're going to just split by space, collect this, and not care about the extra allocation, right? Yeah. Let's operation parts be this and collect this into a vector. And let's say if this is a left-hand side, an operator, and a right-hand side, we're going to slice this. Or we can say, let this be this, else panic, valid operation, yeah, operation format, whatever. And I guess even for the operator part, we could, well, we can do the matching now. Okay, so let's now do, what are we going to do? Let's, I guess we can parse the left, we have to parse the left hand side, parse ID of left hand side, and we're going to do the same with the right hand side, and then finally do a match of this operator. And I seem to have some problem here. Let this be this. Where is the syntax problem? Oh, I have a backtick there. That was ugly. Okay. Now, what is op? This should be, well, double string slice. That's not very good. And now it's better. So if it is, well, plus, we're gonna say what? Oh, we can construct. We had already done this. So yeah, let's say let's operator b op add and do the same things, but minus this and this, and let's say sub mul and div, and finally here let's return a monkey job op with this operator, left hand side and right hand side. Okay, isn't this beautiful? Yeah, beautiful parsing code. Anyway, where were we? Do we have an error here? we have the monkeys. I could maybe try to format this, format, but I think I'm gonna need to implement display or derive display or some things like that. But maybe we can trust that the monkeys are parsed correctly. Yeah, you should need display. Maybe we can have that, let's say, derive debug. And let's do the same for this. And let's see what happens if we do cargo run day 21. And there is a to do. Oh, this is non-exhaustive, so let's say that anything else is unreachable. And this should be invalid operator, and we can even print it here. Sure. Sure. Let's run this. And look at this beauty. Can we print it more betterly? If I remember correctly, this was something like this kind of hack. Yeah, look at that. Very. Now it's much better. These numbers for the IDs, they are beautiful. I could maybe make this ID an opaque type, but I don't really care about that. Does this look... Oh, and they are not even in order because this is a hash map, so this didn't explode, so let's trust that is doing things okay. Okay, yeah, let's not think about this. Let's try to implement the thing that we need to do. So we want to evaluate what root says. So we're gonna have a function. Let's call this eval, as traditionally it's called in computer science. It's going to return one of these numbers. And what's it going to take? I guess we're gonna need this map of monkeys. So yeah, we're gonna need, I guess we can pass this an ID, type monkey ID, and the monkeys. Sorry, this should be a hash map of monkey ID to monkey job, and I think that's it. Is this enough? So one thing that I don't know is if we need to do some sort of like memoization of the results or something. Like for this example, it's pretty trivial, but for the actual example that's actual input that has many more monkeys, if any given monkey is evaluated like many times, so let's, for example, search for this, how many appearances there are. Well, only 2 actually. Let's search for another one, only 2 also. So yeah, maybe doing memoization is not necessary. And I'm saying memoization, but maybe you could do, like, we could also have some other parameter here, like a mutable cache, to store the intermediate values, so we don't recompute things all the time. But maybe we don't need to do that. So let's assume that let's do the simplest thing first. So we're gonna do what? Let's say let answer 1 is gonna be eval of the ID for root, which we can do as parse ID root, and these monkeys. Yeah. And we're just gonna have answer 1. And here's the meat and potatoes of our problem now. Okay, so how are we going to do this? We can start by saying when we say monkeys get ID, this will return a option, right? Yes. So let's say let some job be here, or else panic ID not found. Why do you care? Because you need a reference here. Okay. Oh, and the ID, well, just debug printed there. Not very nice. We could probably have a ID to string. Meh. Let's leave it like this for now. Then we know we have a job, and we can just match, I guess. If we match this job, and if this is a num, well, monkey job num of n, the evaluation is just going to be n. That was easy. And if it is otherwise an operation, but we have an operation left-hand side and right-hand side, then we are gonna do, well, we're gonna evaluate the left-hand side. So eval left-hand side with the same monkeys, and right-hand side is gonna be eval of right-hand side with the same monkeys. And then we're gonna do another match, this time on the operation. And this operation can be, can you maybe autocomplete everything? I seem to remember there being some like recent Rust analyzer news that you could autocomplete all of these guys, but well, okay. Let's say add is going to be something, blah, 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 sub div. Actually, let's write what add is going to be. Add is going to be left hand side plus right hand side, and then have this be the same, sub mul and div. Yep. Left hand side here. This is a reference. Sure, you can dereference this, I think. No problem. This is also a reference. No problem. I guess we can just dereference the job, right? Or maybe we cannot do that because it's not copy. I'm not sure. No, not this. But if we get it like this, yeah, then we don't need all that dereferencing. Oh, but this complains because move out of, yeah. Consider borrowing the pattern binding ref. What is that? No, not in get. Now, okay, so we probably need to implement copy or something like that for that to work. Whatever, let's do the simplest thing here. Okay. And I think, is that it? This eval code was pretty straightforward to do with the modeling that we have done. So let's try it out. We have the sample input and it's 152. That was the answer for the input, for the sample input. So let's copy the actual input now. Okay, rerun this and it's a gigantic number, but we run this in debug mode, so there were no overflows. That's good to know. Let's see if this is the correct answer. And it was. Nice. This was a pretty simple part one, like much more straightforward than the previous 2 days, I think. So that's good. A good change of piece, I guess. Let's see what part 2 is about. And I have my mate so stuck. Okay. Due to some kind of monkey-elephant-human mistranslation, you seem to have misunderstood a few details about the riddle. First, you got the wrong job for the monkey named root. Specifically, you got the wrong math operation. The correct operation for monkey root should be equal, which means that it still listens for the 2 numbers for the same 2 monkeys as before, but now it checks that the 2 numbers match. Second, you got the wrong monkey for the job starting with humn. It isn't a monkey, it's you. Okay, actually, you got the job wrong too. Okay, you got the wrong monkey and the wrong job. You need to figure out what number you need to yell so that root's equality check passes. Oh, the number that appears after human in your input is irrelevant. Okay, what number should I yell so root is equal? Okay. In the above example, the number you need to yell to pass root's equality test is 301. This causes root to get the same number, 150, for both of its monkeys. Very interesting. Okay, so in the example here, where is human? Human was 5. But this is my job now. And where is human used? It's used by this, which in turn I guess it's going to be used by something else. And in turn it's going to be used by something else. And finally, not finally, here. And finally it's going to be used by root. Very interesting, okay. So this is one of those parts 2s that are like very different than part 1s. So part 1 was quite straightforward, just do a calculation. And now part 2, it seems like we have to do like an inverse calculation, something like that. Like it seems almost to say that this is solving an equation, right? Because it is. It's going to, like root is going to say these 2 should equal something. Yeah. And in this case, in the sample, our number was used only on one of the root parts. But I don't know if in the actual input that's gonna be true. So let's check that. Human is used only once, okay. And this thing is used only once, okay. I wonder if this is going to take a long time, because maybe it is. It is a very long chain of things. Let's follow it a couple more times. Yes, it seems like they're all being used only once. No, yeah, this one also. This one also. At some point we should get to the root. Okay, let's assume that this continues on, because we have like almost 2000 lines. I don't want to continue doing that. Oh, and root is not the first one here. Root is this. Okay, so now we don't have to say evil. We have to say something else. Very, very cool. So let's try to play out a little bit with this. Or I guess before anything, I kind of liked this part 1 solution. Yeah, I think it was pretty straightforward. So let's add this and add a commit for this. Day 21, part 1 solution. Okay, let's experiment a little bit with this. In the actual input, root also says plus, as it said in the sample. But let's do something. Let's do, well, we have answer 1 here. Let's say, let's no, monkey job, why don't you like this? Operation up left hand side and right hand side. Let's inspect what root has. Actually, like, we know what root has here, so we have these two. Let's do something. Let's print line root left hand side is gonna be equal to eval parse ID of this thing and the monkeys. Okay, and root right hand side is going to be this thing. Let's run this. Well, we have two big numbers. I don't know what I expected, but we can introduce okay, I would like to know which of these two parts is affected by the human, right? How do we do that? Well, we can panic maybe when we get to evaluate the human. Can we do something like, I wonder something about Rust. Can we do const human ID This will be a monkey ID and say like parse ID. Human. Do you like that? Non-const function in constants are limited to constant functions, but can we make this function const? Can we say something like this? No, because try into is not a constant thing. Bummer. Okay, that's fine. That's okay. We just need to do this here. So we have this, the evaluation. Let's add a precondition here, or a check, to see if this ID is equal to, well, what we have here, the human ID. Then we're gonna panic and set nasty human. Okay. And if we run now, we should get the panic. We got nasty human before printing anything, so I guess that was on the left hand side. If we comment this, no, it panicked again. Oh, but because it's panicking because also we are needing to evaluate root, so let's not do that. Let's do this and let's run again. Okay, it printed the right hand side, so I guess the human is used for the left hand side then. Yes, there it panicked. Okay, so we know that the human thing is on the left hand side. I don't know why I wanted to. Yes, I do know. I wanted to know that human is being used only once on these two sides. So we know that one of those is like a constant, and the other one is going to be like I don't know, a math formula, let's say, but we're gonna have to do sort of like an equation solving, right? So like we need to know what number I, the human, should be yelling. So let's search here for human. Here it says this number. Well, let's actually think with a sample. How do we figure this out? We have this human. Highlight all. So here we say that this is the human variable, so that we can think of a math variable x minus this, which we could also rewrite as saying my number is gonna be this plus this, right? I guess so. Yeah, and then we can, okay, say, well, what is this plus this? Well, this is 3, and this is another equation, is this, which we could say, okay, this is gonna be this divided by this, right? Kind of. I don't know if divisions, because we are using integer divisions, okay, and so on and so forth until we get to the root where we know that we have to be like equal to something else. Right. I think so. Can we do this thing like in reverse? Can we do this? Damn, this is very interesting. Very interesting. We also have like 2000 things. So I'm trying to think like logically what we need to do. But we also have like 2000 monkeys. So we also have to think of like if we have all of this in a hash map, and we have to like look for because we can look for the human definition, but it doesn't say anything by the ID. We will have to look in the values, like which job is using the human, and then use that to know like the formula for this, and then through like a sequential lookup in the values of this hash map, which is not ideal, I think, but should be fine, I guess. Is this what we want to do, though? Is this what we want to do? I don't know. I wonder if there is another approach of doing this. Which could be something like, okay, for the root, we could do like a sort of symbolic evaluation, where it's going to say, okay, one of these two, this one, can resolve to a number, but this other one could resolve to a sort of expression tree, which would have would have like expressions, operations. Like this thing, for example, is the division between these two things, and this is each of these is going to be like something, and some of like until some of them are going to include like the variable that we want to compute, and then all of that has to be equal to something, but we have to solve for that variable. We have to solve for that variable. So I don't know if that makes any sense. Right? I think the first train of thought that I was having seems a bit more promising. So I wonder how we could achieve that. So we know that this eval is fine. What else? These IDs kind of things. We can leave this first answer. It wasn't slow or anything, right? I think it wasn't. Even running on 5 milliseconds is fine. Can we do something like let's sketch something different for part 2. Instead of saying eval this thing, can we say something like solve for so we're gonna solve like for a given variable or ID, and we're gonna start with human ID. I have no idea what I'm doing here, but I want to sketch something out. And the monkeys. Whoops. Please generate this for me. Thank you. Although I don't know how useful is this generation. Well, it's not too bad. It's just that it doesn't know, like if these things are of type monkey ID, even if it is a type alias, I probably want to use the type alias, so yeah, I would like to have that. And let's be very optimistic and say that this thing can know the answer. So what are we going to be doing here? Well, I am sort of assuming that these IDs are used only on one operation each. At least this human ID, we know that is only used in one operation, and we followed along a little bit, and we always saw that it was used once in one operation. If it's used twice in the same operation, like human but plus human, or once by more than one operation, it's going to complicate things a lot, because it's not going to be like a simpler arithmetic substitution. But we're gonna have to check if that assumption is correct. I would like to have an assertion of that. Right? Yeah. So by the way, this eval is fine. It's nice that it's also recursive, because here we're doing recursion on both sides of this tree, and otherwise we will have to have like a stack and do nested. Yeah, I was thinking of, does it make sense to change this eval to be an iterative solution instead of a recursive one? I don't know what, that thought came to my mind. Anyway, let's think about this. How would we be doing this? Well, so we have not a parse ID. We can call this thing, this is our variable in a way. These are the monkeys. Variable ID. Right? And we have to find the entry on this map that that includes this ID on the operation, right? I think so. So let's do monkeys. If we iterate over the monkeys, I think this thing is an iterator over key value pairs, if I'm not mistaken. So I guess we can we can find an operation for this, but I would like to assert that it is only one. So how can we do that? We can count, I guess, but I don't want to allocate. But I would also like to short circuit if I find the correct one. Maybe we can use iterators for this. Of course, we're going to use iterators, but I mean we can probably save this iterator, get the first one, that's the one that we are going to use, and then try to get the next one. And if we succeed in getting the next one, it means that this variable ID is being used in more than one monkey operation, and that's going to make things more complicated. So let's say, how long has it been since I started recording this? I don't remember if I started at like 7, but if I should take a break or something. But let's try to follow along this for a little bit. So here we're gonna have an ID and an operation, no, a job, right? Yes, and we want to find, let's say something true, I don't know. Let's say let's mute, we're gonna keep this iterator. Monkeys, what is it, like monkeys that use this thing. So var, we can say var uses, it's going to be this, and since we are filtering, we can get the first one. So let's sum. This is going to be a tuple. So, and this is basically an equation, right? Any, or like each of these lines is like an equation. Where we have the left-hand side, the thing that equals something plus something, or something operation something. Okay, maybe I want to first sketch this out. So we want to find the variable uses of this. We're gonna match the job then, and if it is, well, if it is a number, then whatever, we're gonna say false, right? We want this to match, oh yeah, we can say something like monkey job operator, any operator, I don't care, a left-hand side and a right-hand side. So if left-hand side is equal to var id, or right-hand side is equal to var id, then true, this is a use, sure. Sure. Well, anything else, let's say false. So we can probably remove this. Here, left-hand side is a reference, and yeah, we can dereference this. Sure. We can also maybe be a bit paranoid and ask if the left-hand side is equal to this and the right-hand side is equal to this. In this case, I want to panic. Maybe it's not the best place to do this here, but let's say var or yes, variable, and we're going to put the var id here used twice in this id. Sure, and we're gonna, I think I want to have a function that like the inverse of this parse id. So let's say id to string, and we're gonna just pass var id here. We don't like this because, oh, and this id also. So here also var, no, id to string of id. Yes, let's put it here. Then id to string is gonna take an id of monkey id, and it's going to return. No, we cannot, well, we can allocate for this, I guess. Sure. Can we? Can we say like stir from or string from raw parts? It's an unsafe thing. UTF-8 from string slice. I guess it's from UTF-8 what I want. Yeah, not this. First string from bytes. From the UTF-8 lossy. Okay. Oh, there is a stir from UTF-8 that takes what I want. So can I say stir from std stir from UTF-8, and just maybe we can pass a reference here and just pass this. We can do this maybe and inherit the lifetime. Well, just use unwrap here. I don't know what would be a correct message for this. Yes, this is all right. You can pass a reference here. Yeah, look at that. Okay, but it will use it twice. I guess we can use this same function here, id to stir, and pass, yeah, the id. Great. Okay, so we know that var uses contains job operators or monkey jobs that include the thingy, the var ID that we are looking for, right? So maybe let's print something. So what are we going to do here? I'm wondering if I should unpack this already. Instead of saying true, maybe saying do a filter map, and here returning a tuple of these three things. So then we don't have to deal about the simple number case or anything. Like we won't have a job, monkey job. We will have just the tuple of these three things, I think. Let's do that. Instead of filter, let's say filter a map. And so then instead of saying true, we're gonna say yes, this is some nice thing, some nice operation, left hand side and right hand side. The operation is gonna be this, and we are gonna extract this, and otherwise it's gonna be none of your monkey business. Okay, so now we want to say let sum operation left hand side and right hand side be this var uses, and next else panic found no uses of id to string id, no, var id. Okay, and now we know that these are the use, this is one use, so we can also say let's do a check here. Let's assert that var uses next is none. There should be no more than one use of id to string. Why is this assert broken into different pieces like this? I don't like this too much. I would like this to be a one-liner. And say, if there is some other use. Oh, by the way, we need more. We need more than this. We're also going to be needing the ID of this job. Yeah, beautiful. So let's return then something like this. Here we're gonna call this use ID, and here we can say something like, if there's some other use ID, of this thing, var uses next, then we're gonna panic and say found more than one use of ID and we're gonna have ID to string of var ID, yes, and then also ID to string of use ID and ID to string of other use ID. And look at that beauty in the name of debuggability. I am thinking of making these IDs an opaque type and being able to inline those things here. I will probably do that in a refactor of this. But let's keep on going with this. Okay, so we have found one use. So now here we know that we are doing this operation and that either left-hand side or the right-hand side is the same as var ID. So we can then recursively find uses of this use. Like we can, for example, if it is the left-hand side, the var that we are trying to solve for, we can evaluate the right-hand side using eval, because we know that on the right-hand side is not going to be used, like the human thingy. And then do this solve for recursively on the use ID until we get to the roots, I think. Let's do that. Let's do the recursive call. First, let's print something. So print line. Say is used on as say everything. The only thing that we can put here is maybe OP, and for that we're gonna have to say derive debug. So what is used? Well, ID to string of var ID. So it's used on id to string of use id. Is use id a reference? Yes, it is. And this is going to be op. So id to string of the left hand side and id to string of the right hand side. Yeah, what a beauty of a print. And then let's do the recursive call, solve for use id and the same monkeys, and we're gonna return that. So we don't have any break condition, so we're gonna break when if the var id is equal to root. So if this is the case, we're gonna print the line reached root, and let's return something, 42. All right, we have no compiler errors. Let's see what this prints. A lot of things, but it terminated, yeah, and it reached root, and we don't have any of the errors of having double uses, nor finding another one. That's very good. And we have the actual input here. So I think we proved that our assumptions were correct. Let's go to the sample input, which should be much less noisy. Human is used on humans of this. Then is used in something is this small this. Great. And then this is used on root, and then it reached root. Okay, the recursion is fine. That's very, very good. That's very, very good. The code is a bit messy, but the recursion is fine, which makes me happy. Now we have to do the actual calculation of getting to the answer. So how are we going to do that? I don't know. Solve for. So let's check this. So I'm pretty happy that we got to check that the double uses and those things were not breaking everything. So let's try to actually break it and check that our assertions are working. For this kind of thing is also the case where maybe having some unit test would be good, but let's not think too much about that. So let's see, human is using this, human in this rule, and this rule, so let's copy this, let's find this here. So this rule is used here. What if we have another rule, like another rule that uses this? Well, first let's check something simple. Let's see if this is used twice here. It should explode. It didn't. It's used on this. but it's used twice. Oh, because our check. We are checking. It was a good idea to actually check if we were doing something. So I think maybe maybe we can do this check. Like, I don't think it makes sense to do it in this match. Here we want to see if it's being used. More than one use. And let's say here if left hand side is just equal to right hand side, then we're gonna panic and say variable that is used twice in this. So the variable, well, we can pass the same parameters here. And here it's going to be the use ID. Okay, we don't need to do this, I think. Let's run now. Yes, variable ptdq is used twice in LGVD. So LGVD, yes, is using this twice, so this is working. If we go back, we reach root, and if we put another use of ptdq, let's say that this is plus ASDF, and this is going to be this. So if we run now, found more than one use of ptdq. This and this. Yeah, really nice. I guess we can just say found more one use of this, and we can then search for the use. Yeah. No need for such level. Oh, well, if we change used in and if we then make these things printable, it's going to look better, I think. So let's leave it like that. Great. So we can go back to the original, which is this, I think. Should run. Yeah. Okay, so now how do we solve? Well, we have the cases where left-hand side and right-hand side can be different cases, right? So it's not the same if you're dividing by something or you are, like in multiplication and addition, being the left-hand side or the right-hand side is the same. But in subtraction or division, it's not. So we have done all the precondition checking. So what are we going to do? What happens when we reach root? Well, when we reach root, solve, yeah, that's what we can start thinking of. The breaking condition won't be this, I think. I think it would be something else, like if the use ID here is equal to the root ID. Then we are solving for root. And here we have the answer. We know the answer. So then if the left-hand side is the variable that we are solving for, then we'll return the evaluation of the right-hand side, right? With a monkeys. So if the left-hand side is, in this example, this PPPW, we're going to reach root with that, right? We say, okay, PPPW is used in root, in this, and we know that in root add doesn't mean add, it means equal. Then we know that PPPW should be equal to, should solve to this, whatever this evaluates to. So yeah, we can say this, I think. And here, right hand side, we can dereference this. Maybe we can pass this variable IDs as references, but instead of having to dereference things so much, let's keep dereferencing. Yeah. Right, and else we know we are using it on the right hand side, so it's going to be the same eval of the left hand side and monkeys. And this if else can probably be reduced here. Say let's we can see make this right. Well, we can say other this if condition. Well, actually, the return, yeah, and return eval of other with these monkeys. Okay, beautiful. If it is the left hand side, then it's the right hand side. Yeah, this is the other side. Yeah. Let's print this println. And should we maybe print this extract to variable? Should be equal to res, and is our var id, right? Come on, what don't you like? Oh, the other way around, okay. PPPW should be equal to 150. And I think yes, SJMN is 150, that's fine. So now we need, okay. We have the base condition, I think. I'm not sure if I'm thinking of this correctly, but if we are solving for PPPW, PPPW should equal 150. That is correct. Now we have to correctly solve for all the other stack of things until we get to there. So this is correct. It's going to be a lot of cleaning up afterwards. But now we should think before reaching root. Root is this, and this is not an add. So this is a special case, and it will be the termination case. Now, PPPW is this divided by this. And this is the variable. So if we know this, let's think of the different cases. Let's see. We have two cases, being left-hand side or the right-hand side. So if our use ID is equal to the left-hand side, if it is the left-hand side, then let's say match the operation that we have. I guess we can borrow probably this thing. Can you come on, how to complete this thing? I'm pretty sure that the language server knows how to do this, but I don't know how to do this. Okay, so let's see what happens if it is an addition. We have an example here, like LGVD is used in this. We can pretend it's the other way around. LGVD add this. So we're saying that this is equal to this. So we're going to say it's the same as saying that LGVD is equal to this minus this, right? I think so. And this is the use ID, which we have to solve for. And this is the other side that we can eval. Does that make sense? I think it does. So it is going to be solve for the use ID. As we are doing this, will replace the recursive call of this. The use ID and the monkeys minus the, what they will say, the evaluation of the right hand side. Right hand side ID and the same monkeys. Monkeys are being passed around all the time. Is this correct? There's something that you don't like. Yeah, no, you're going to be the return type. So there's something else here. because of this. Yeah, we're gonna also have an else here, don't worry. Are you happy with this? You're a bit happier. Okay. This, you probably want something like this, okay. And OP, missing match, yes. Can you, yes, fill this, awesome, awesome. That's what I wanted. Okay. So now, if it is a subtraction like this, and we are the left-hand side, this minus this, so if we add this to other side, it means that this is equal to this plus this. We are, I don't remember the names of subtraction operands in English, like subtrahend and subtrahe, I don't know. But yeah, right, if we are the left-hand side, we can add, this is an equation, we can add this to both sides, and this would cancel out, and so it is this, it's this. I think we are always going to solve for the use ID, so that's probably something that we can extract out, and we are probably also going to eval the other thing, so it will be more a matter of what do we do, like what operation do we do between those two. Yes. And this, you don't like it because can't compare this to that. Oh, then yeah, no dereferencing needed. My mate is probably very cold. Okay. Let's continue on. If we have a multiplication, I'm pretty sure, do we have something here? Yeah, this is used, pt blah blah, but it's commutative, so it doesn't matter. We can divide by this on both sides. We assume that there are no zeros, so yeah, let's not care about division by zero, please. So this is going to be this divided by this, okay? Yeah. So again, we're gonna do this divided by, and this is where I don't know if integer division is gonna be fine. We're gonna find out soon. And now, if it is a division and we are the left-hand side, then we can multiply both parts by the right-hand side. This will cancel out, and yeah, it should be that. Times this. I wonder if we are always the left-hand side. Let's leave that as a to-do. What happens if we run now? No, of course, no. Not yet implemented. Why? Okay. Sure thing. We're gonna do a similar thing, and in this thing, I'm pretty sure that the addition and multiplication is gonna be the same because they are commutative. Although here it's gonna be always the left-hand side. Okay, so let's only think about subtraction. So now we are the right-hand side. Is the right-hand side. Yeah. Let's think about subtraction. If we are the number being subtracted, we can I have to think of arithmetic. We can add that on both sides, and then subtract this. So it's going to be, this is going to be this minus this. Okay. So the left-hand side minus the solve for thingy. Unless I screwed something up, which we shall see. And with the division, I expect the logic to be somewhat similar. So if we are the right-hand side of the division, well, we can multiply both sides with this and then divide by this. So we'll have this, the left-hand side, divided by this. Yeah. And again, integer division might screw us up. But let's run this and see what happens. And we panicked. Attempted to subtract with an overflow. Interesting. I guess it's gonna be subtracting with an underflow. But where is this? Here. Okay. Let's do a printing before, but yeah, sure, we can have negative numbers, I guess. Subtracting, well, from and just pass this and see what we have before. No, subtracting this and minus this. Beautiful. Unnecessary recursion. Attempted to subtract, blah blah. Are we here? Yes. Why didn't you print any? Oh, because we are calling solve for, and that is okay. It's 0 minus 4. Okay, so we are going to need negative numbers. Let's trust this thing. So instead of using, what was it, U64, sorry, I have my face over there. We have, oh, okay, only 3 uses of that. That is amazingly good. When we eval and when we solve for that also. So we're just going to change that to a signed 64-bit number. Okay. Yes. Now we shouldn't have any more underflows. We got a number 7, which I don't know if it was. No, in our example, the number you need to yell to pass roots equality test is 301. Bummer. Bummer. Okay. Okay. Let's do some debug printing, because we got a number. Like if the human number is 7, where was human number, if it is 7, then it is, this thing is 7 minus this, and well, we will have to like follow along this. I think if we do some printing, we're probably going to find out where we're screwing it up. So when we reach root, that's the last condition. Let's remove this. Let's bring this reached root. should equal to okay. Then we are gonna, this is the last thing that is going to be called because of the recursive calls. This is gonna be the result, and we're just gonna return this here. We can do the printing here, I guess. This kind of printing. Is used on voa. Let's print another line then. That would say needs to be result. That's what we are solving for. And you don't like this. What's syntax? Let's see what we get. Oh, no, where's my output? My console, my terminal, okay. Reach root, ppw should be equal to 150. Oh, ppw, okay. ppw is cc set h divided by this. So we know in one of the cases we know how the other side, either left-hand side or right-hand side, equals to. So let's put this print inside of here and say something like, here if we are the right, the left-hand side, we are this operation on equal to, let's print it as a formula, operation and I'm getting a bit distracted, and the evaluation of this thing. Okay, let's do the same here. Is used on, but now the evaluation is going to be of the left hand side. Okay, let's run now. Oh, but we have the recursive calls. Beautiful, beautiful, beautiful. Okay, we have the order of the recursive calls, and we have the root should be 150. cc blah 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 is using this 8 divided by this thing. 8 divided by something. So ppw is 8. Here, do we have the correct sample? I don't know if I left something screwed up on the sample. I guess not, but just check. Yeah, okay. ppw. Oh. Is this, and this evaluates to 8, it seems. right? PP value 8. Unless we are, let's see, let's search for this. Well, this is this plus this. This is 4 plus this. Okay, there's a bunch of things, but in PPW, this seems to evaluate to 8. Divided by something. What should we divide 8 with so that PPW is 150? That makes no sense. It should be a small number this then. Oh, that sucks. Like 150 is 8 divided by this. That's a bit insane. I'm doubting this. Okay. Yeah, I'm wondering about like the math of these things. CC said H. No, wait. Here there's something that's wrong. CC said H is used in PPW equals this. We are solving the wrong thing here. We're solving something wrong. Yeah, because here it should say 8 equal, like PPW equal 8 divided by this, but this is not this. We screwed something up. Good. It may not have to do with integer division. So what did we screw up? Left-hand side, evaluate of right-hand side. This is the other case. We are here. Eval of the left-hand side. This should be the case where use ID is right-hand side, right? I guess either one or the other. It cannot be. Anything else? Let's add an if. Right, let's add more printing of this, and blah blah is used as left-hand side of this. Let's run again and be sure to see it's used on right-hand side of this, but this doesn't look like the right-hand side. Yeah. What do we have here? What is the left-hand side then? Let's just go back to this. Was this the left-hand side? I am becoming crazy. Yeah, it's the left-hand side here. So, I'm asking for the wrong variable. I'm asking use ID. This should be var ID. Damn. My variable names. Okay. So does this make sense now? Yes, 301. This is what we wanted to see. Okay. My cat wants to go outside. Maybe I should run the actual input and take her outside. Let's copy the actual input. Should I clean the prints? Maybe not. Let's run it again. And I don't even remember if this was the correct answer for the first part. 19 blah blah 286. Yes. Let's try this number for part 2. And yes, we got it. Yes. Wow, this one was very nice. What a nice challenge. This is not USID, this is var ID. I should probably clean this up. This print should go away, this should go away, this should go away. See, Simone. This should be inlined. This can go away. Do you have any other prints? Yes. Reached root. Sure, go away. These. This should give us the same number. Yes. And it runs in a pretty good time. We don't have to do any sort of memorization or anything. Release. In release mode, it takes 2 milliseconds. That's awesome. So this was not a performance puzzle. It's more of a, I don't know, math modeling kind of puzzle. So let's annotate this a bit better and maybe improve some things about the code before committing. We have a working solution, so let's first add this. Here we can say that the equation is something like use ID equal var ID up left right hand side, and in this case is left hand side operation var ID. So let's extract some of these variables. This, I guess we can replace arithmetics. What is this? Oh, no, I don't want to do that. Well, let's copy this. Let's use ID results. It's gonna be solved for this. And we're gonna replace all of this with this. Okay. And the evaluation of the right hand side, we can put it here. Let's well, we can use the right hand side here. Why not use some good old variable shadowing? Side, yes. this is like the left-hand side of the equality. So how do you call this thing? Like a term, each term of the equality. I don't know how the two sides of an equality are called, because this use ID, the idea of use comes from these find. So, well, you can think of better variable names later, i.e. never. Let's also put this into left hand side. I guess to be consistent with what we did before, we can call this left hand side results, and this other thing we can call right hand side results. And this should still be the same thing. Yes, it is. Beautiful. Let's add a comment here. Let's say solve the math equation depending on whether our variable is the left hand side or the right hand side. Yeah, okay. We can have something like this. Then this is the root case, or the last case. And I guess the only thing that I would like to change is this printings, not have so many ID to string kind of things. No, we don't want to. Let's add these changes. I almost reverted my changes, although it's no problem if we do this with Git here. We can still do Control-Z over here. Oh, we can clean this up. Yeah, we have the root ID and the human ID. Very pretty. Don't think we need to derive debug, do we? No, we don't. We do not. Okay, so let's see, Makalu. My cat wants some attention. Okay, let's finish this up. Putting this to string transformation. How do we do that? I guess we can implement display or debug for monkey ID, but in order to do that, I don't think I can do this with a type alias. If we say impl debug for monkey ID, do you like this thing? Macro debug. Okay, so it is FMT debug, and yeah, import this. Can I implement this, or is this a problem? Yeah, no, I cannot not do this because it's not my, like, this is a type alias, so it's basically another name for the same type. Yeah, does it make sense to do a struct monkey ID like an opaque thing? Maybe it does. I can implement this, but then I have so many other problems. Well, ID to string is the one that I will change. I have to implement equality, cannot be dereferenced. Yeah, sure. Let's make it derive all of that. So it's going to derive what things? Partial, EQ. Let's see what things it doesn't have. Consider, yeah, EQ also, and I guess since we are hashing, it will also need hash. So with that, this is happy. Then yeah, try into for these. I guess we can say monkey ID of this beautiful. So beautiful. And that's it basically. With that, it is happy, and I can implement debug. And in order to implement debug, I just want to say, yeah, it's the string, you know. So I want to do basically, it's a formatter. Okay, so I just want to do this, I think. This of ID 0. We're not gonna unwrap, I guess. Well, we can do this. And I guess this is self 0. What's your problem? Do this. Let's S be this, and F write string S. Yeah, look at that. And can I do, instead of unwrap, use this? Probably not. What is the problem? Yeah, from UTF-8 error. I would have to like map the error to a format result. So can I cannot do into or anything like that. Map. Can I map error to yeah, you know what? I don't care about this error. Just unwrap it. Unwrap the thing. And now ID to string should be unnecessary. And let's see which places break, because this doesn't exist. But okay, now we should be able to say, hey, put the ID here. Yay. And found no uses of this thing. So let's say var ID in here. I need to do this, right? Otherwise it's going to complain about display. Okay. And here it's var ID and use ID and other use ID. At least this panics look much better now. And this should be var ID. And finally use ID used twice in here. And this we cannot do because it doesn't implement copy. But of course we can make it derive copy. It's what's the problem? Why don't you like? Oh, copy needs to be clonable. Of course you can clone this. Yes, and now it's happy. Now it should run the same. The logic didn't change. It is the same result, right? Go back. 086. Yes, it is the same result. I wonder if here we have this kind of error. If there is a nice way of like lifting this error to this type, I don't know. Parse ID could probably be improved. This can be something like this. How did this code look before? Okay. It's not too great either. Both ways are pretty ugly. Maybe let's leave it this way. So we have the parsing, then evaluation and solving. Yeah, let's say that's implement debug just to have better error messages in case of better assertion messages. And actually I think most of these panics can probably be turned into assertions. But let's try to break some of this. I guess we can say found no uses of var ID. Yeah, this is fine. This I think other use ID. Can we say something like this? Yes, you can. Awesome. More than one use of something. Okay, let's do that. Let's do human. We're gonna have more than one use of human. So we're gonna say ASDF is blah and human. If we run now, found more than one use of human. using this and this. That is awesome. Maybe we can put like inverted commas. Actually, we can probably do that here when we write this. Write fmt. This is a macro, I guess. So can we do something like, how does write fmt work? Oh, format args. Wow. Okay. What a complex thing. Wasn't there something like a write macro? Yes, there is this. So I think we can do something like this. We can put the commas, inverted commas inside. Yeah. And if we run now, found more than one use of between commas using, yes, I like this better. This is pretty good. This is pretty good. So we have different panics and conditions. This panic can easily be turned into an assertion. Assert that left-hand side is different than right-hand side. And that's it. Here, I guess we have to extract this here, so this is fine, I guess. Yeah, this is other ways of preconditions. So yeah, I think this is more or less good. When it's used twice, maybe we can try that. So here we have this. Oops. Let's use it twice. Let's use it twice here and see the error. Oh, Stack Overflow, core dumped. That is bad. I think I screwed it up. Yeah, I don't want to. Sorry, let's revert this. Yes, discard all the changes here. So, yeah, we don't have limits of stack limits. That's a bummer, but well, what can you do? Yes, this is used twice in this thing. Beautiful, beautiful. That is a-okay. And the variable names here are, I think, questionable. We're solving for this variable. This I'm okay with. Bad uses, I'm okay with this. Use ID is like, I don't know if I can think of a better name for that. Yeah, other than that, this looks quite okay, I think. The eval is pretty straightforward. Then we have this parsing methods, functions, and yeah. let's add a comment here. So why don't we use a use a 4-letter array for monkey like this instead of string slice to avoid having to annotate, avoid having lifetime annotations on monkey job. Having to we're having explicit lifetime annotations everywhere. Okay. And what else? And use opaque struct. So instead of a type alias, so that we can implement debug for it and interpolate IDs in error messages. Yeah, I sort of like having these explanatory comments of why I did certain things, and this is no longer needed because we are already explaining this over here. All right, let's give a final look to the code. Here we're parsing monkey. This looks fine. Parsing an ID. This looks fine too. I wonder if there is a better way of doing this, but this seems to be fine, I guess. Yeah. Parsing a job. This is fine. Then we have the parts that we match to this invalid math operation format. Yeah. Maybe I should be consistent between panic and unreachable. I'm sort of using them a bit interchange for the same purpose, but I'm just putting unreachable in like match conditions that I think should be unreachable. But this isn't actually unreachable. Like if I put here a different operator, like I don't know, ampersand, this is going to fail. Sorry, this is going to fail with something like entered unreachable code, invalid operator, and so it's not really unreachable. It's like if I were doing error propagation correctly, this should be a recoverable error, and say like, hey, there was a parsing error, and that's it. Deal with it. But yeah, I don't think unreachable is the correct thing to do here, but it's fine. It's just what I'm assuming this to be. Okay, and here we parsed a monkey job correctly. Then the eval code, which was pretty simple, I think. Yeah. Here we are also using ID interpolation. And the solve for, which is quite more complicated. This line is a bit noisy, but I think it is doing what I want to do. Yeah, we're just extracting things here. And then using this. And if there are more than that, I could get rid of all of these assertions and just assume that things are going to be, like the code would become a bit cleaner. And it's not like I really care about being super robust here, but I prefer to leave these assertions like explicit. So if I come back to this at some point, it's like, okay, what assumptions did I make? And the assertions are basically documenting those things. So yeah, let's leave them on. Yeah, let's say when we reach the root equation, our var ID must be equal to the other operand, to the other side, operand, let's say. Okay. Then here we are doing the recursion and then solving equation depending on where. Okay. Yes. Okay, I'm feeling pretty good about the shape of this code. It ended up being not such a trivial problem. The part 1 started pretty easy, but part 2, yeah, I had to actually think for a little while. So let's commit this. What did I have as the previous commits? Yeah, I only have part 1 solution, so let's have day 21 complete solution. Very nice. Okay, so I think that's it for today. If you have been, thanks for watching and see you next time. Goodbye.